In this video, we will look at p-values in a statistical hypothesis test. So remember the components of a hypothesis test. The 5 basic steps here. We start by stating our null and alternative hypothesis. And again, these are statements about the mean or the proportion, whatever population characteristic we're testing. Then we calculate the test statistic. So this is where we plug in our data and we calculate a z-value or a t-value. We then use this test statistic to find our p-value. The test statistic will give us a number. We'll take that number and go look it up in the table, and that's how we find a p-value. So p-value stands for a probability value, so we're finding a probability. So more specifically, a p-value is the probability of being at least as extreme or more than the observed test statistic. So another way to think of it is, we take this test statistic, a number, maybe I get 2.7 or negative 1.43. I'm going to go look that up in the z table or the t table, and I'm looking for the probability further out in the tails. Now, whether I look for above that value or below that value depends on my alternative hypothesis. If I have an upper tail test, my p-value will be a probability of being greater than my test statistic. If I have a lower tail test, my p-value will be the probability of a lower tail. If I have a two-tailed test, I'll find the probability of being outside of my test statistic and multiply by 2, so I account for both tails. So then we use this p-value to determine our conclusion, our test result and our conclusion. So remember, the idea is the p-value, the smaller it gets, the more evidence we have against H0. So the smaller a p-value, the more likely we are to reject H0. So a small p-value leads us to reject H0. Or another way to think of it, as those z or t values go further and further out in the tails, that's more and more evidence against H0, and we should reject H0. So we'll look at p-values with the z table first, and then we'll look at p-values with the t table. So if we've got a z distribution, there's a couple of things we could have. We could be testing a mean, like this first one, where we assume sigma is known. If we assume sigma is known, this is a z-test. So suppose we have this example. We're testing the mean is 10 versus the mean is greater than 10. So this is an upper tail test. So the p-value, I'm going to take that calculated test statistic. I got 1.78. I'm going to look for the probability of being greater than 1.78. So I'd go to my z-table, look up 1.78, I get 96.25. Now remember, this is an upper tail test, so I want greater than 1.78. So that 96.25, remember in the z-table, is lower tail. So if I want greater than, I go 1 minus. So the p-value for this particular test would be 0.0375. Another place, suppose we had a lower tail test. Mu is 45 versus less than 45. And here, suppose our calculated test statistic was negative 0.71. So this is a lower tail test, so I'm looking less than negative 0.71. If I look that up in the table, I get 2389. So I'm finding that test statistic and looking it up in the table. Now we could also have a proportion. Remember, proportion tests are also z-tests. Now this one, notice, is a two-tailed test. My alternative hypothesis is not equal to. So when I find my test statistic, notice here it's a negative 1.02. So it start by finding the probability of less than negative 1.02, but then I'm going to double that because it's a two-tailed test. Again, the idea is you plot your test statistic sort of on your z-table, and you're finding the probability outside of that. If it's a two-tailed test, I would double it. So this particular p-value would be 0.3078. So again, the first example here is a lower tail or a one-tail test. The second one is a two-tailed test. So with z-tests, you can find the p-values by looking them up in the z-table. Now, if we move to the t-table, so this is the case where we're testing a mean, but we are not assuming standard deviation is known. So we approximate with the sample standard deviation. So this is a t-test. So if we had an example like this, mean is 5 versus the mean is greater than 5. Suppose we took a sample of 8 and calculated a test statistic of 1.44. So again, the p-value is the probability of being more extreme than your test statistic. So that would be greater than 1.44 because, again, this is an upper tail test. So I want further out in the tail than my test statistic. So if I go to the t-table here, and I want to find the probability that t is greater than 1.44. So remember, with the t-table, the first thing we need is degrees of freedom. So I take my sample size minus 1, and I get 7. So I go down to 7 degrees of freedom. So all the numbers going across that row at n equals, or at degrees of freedom equals 7 are the t-values for 7 degrees of freedom. Well, notice 1.44 is not in there. But notice it would fall somewhere between these two values, somewhere between 1.415 and 1.617. So notice 1.415 and 1.617 correspond to a one-tail area of 0.100 and 0.075. So if my t-value is in between, it would make sense that my one-tail p-value area, would be between those. So from the table, I could conclude that this p-value is somewhere between 0.075 and 0.1. So notice with the t-table that's in your textbook, we can't find the t-value or the p-value exactly for a specific t-value unless it just happens to be in the table. But in this case, it's somewhere in between, so we can approximate it. Now, notice I could still draw my conclusions. If alpha was 0.05, these p-values are bigger than alpha, I would fail to reject H0. In other words, these p-values aren't really, really small. So I don't reject, I fail to reject. Now, when you're working on the homework, oftentimes they ask for that exact p-value. Okay, so there's a couple of resources you could use to find the p-value exactly. One is this website I've referred to earlier, stattrek.com. It's got a bunch of online statistics calculators and statistical tools. And if you go to stattrek.com, it looks something like this. And notice down the left side, there's all sorts of options. There's some tutorials, a lot of AP statistics stuff. Then notice all the tables. We've used the binomial table out of our textbook. We've used the standard normal table. That's the Z table there. And notice down at the bottom, there's the t-distribution table. Okay, so if you click on that t-distribution table, it comes up something like this. And so notice, you can put in a degrees of freedom, you can put in your calculated test statistic value, and then it will give you the cumulative probability. So it will essentially find that probability or that p-value for you. So if we go back to the example we just had, mean was 5 versus mean is greater than 5. If n is 8, the t-value was 1.44. So we're looking for p greater than 1.44, and from the table we approximated it somewhere between 7.5% and 10%. Well, if I go to StatTrak, plug in 7 degrees of freedom, a t-score of 1.44, notice it gives me a probability of 90/35. Now remember, just like the standard normal table, StatTrek's a cumulative table. So it gives you lower tail areas. So the probability that t is less than 1.44 is 90/35. So if I want greater than 1.44, I go 1 minus that. So here my p-value would be 0.0965. And notice it's in that range that I found from the table, but I've now found it exactly to 4 decimal places. So oftentimes when you're working your homework, it's good to open this StatTrek website in a separate window, and you can calculate these p-values when you're doing t-tests. So one more example. Suppose I'm testing the mean is 100 versus the mean is not 100. So here we have a two-tailed test. Suppose n is 38 and we calculate a test statistic of negative 1.04. So since this is a two-tailed test, we're going to find the probability of t less than negative 1.04 and double it. So if I go to StatTrak, plug in 37 degrees of freedom, sample size minus 1, a t-score of negative 1.04, I get 0.1525. So the lower tail is 1525. So if I double that, I get 3050. So a two-tailed test, the p-value would be 3050. And so that's one way to find p-values using StatTrak.com. Now you can also use the TI-83 or the TI-84 calculator. Those calculators have the TCDF function built in, where you can plug in a lower limit, an upper limit, your test statistic value, and a degrees of freedom. So you can find p-values using your calculator as well.